Okay, this is my solution for the problem that we did on Monday of week 5. And we were talking about holding an object against a wall. So you can hold a block or a book or anything against a wall just by pushing on it if there's friction. And this is what we're going to show. So the problem that we did on Monday was wood on wood. So you can look up the coefficient of friction. In order to hold it there, we're going to look up the coefficient of static friction, and let's say for the sake of argument that's 0.5. Okay, so we do this problem the same way we do all of these problems. We draw a free body diagram for the block. The normal force due to the wall points this way, and your push is this way. Gravity goes down, of course, and the force due to friction is going to go up. Now remember, the force due to friction friction opposes motion, and the maximum for static friction is this coefficient times the normal force. But I'm going to do the same thing I always do here. I'm going to pick axes, so I'll pick these, x and y, and then I'll write that the sum of the forces in the x direction and the sum of the forces in the y direction is equal to the mass times the acceleration in the x direction, which is just 0 for this problem, and mass times the acceleration, which is just 0 in the y direction for this problem. It's actually not accelerating anywhere. So in the x direction, I have a negative normal force and a positive pushing force. And in the y direction, I have a positive friction force and a negative mg. So I'm going to rewrite this set of equations now using what I know about friction. So I know that I'll just rewrite this here with the normal force. But where I see friction, I'm going to write it instead as mu times the normal force. And so I can solve one of these equations for the normal force and then substitute that back in. So I have mu s. Now instead of the normal force, I write F push minus mg equals 0. And so the pushing force is equal to mg all over mu s. So for our example, you have to push at twice the weight. And you should try this if you haven't already. Okay.